If the model should return data, don't disguise it as an action. We'll separate structured outputs from tool calls, so schemas, retries, and side effects stay under control. You'll learn the shape of a workflow that separates data returns from actions and keeps retries away from side effects. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Large language models often mix two things that should be separate. They can give you a clean piece of data, or they can request the system to perform an action that changes the world. When those two blur, you get accidental refunds, duplicated emails, and debugging nightmares. What we want is a crisp boundary. Model suggests data, your app decides and runs side effects. The intuitive idea is simple. Ask the model to return a structured object when you want a value. Treat tool calls as proposals when you want an action. Keep retries and validation on the data side. Only after your app approves do you perform side effects. That makes testing, monitoring, and observability practical. We will build a tiny decision flow that shows the difference. You will see how a model return becomes a parsed object, how a proposed tool call becomes gated, how retries happen only for parsing, and how a single event captures mode and side effect decisions. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. We start by creating the smallest decision frame so we can see the boundary clearly. This snippet creates the smallest decision frame for choosing structured outputs or tool calling. Teams get into trouble when every result is treated like an action, or every action is squeezed into a data schema. The tasks dictionary marks whether each task can create a side effect, and routes turns that into the boundary choice. Extract total stays schema only because it returns data. Send refund becomes a tool call because it can change the outside world. The visible output shows how many paths are safe data returns versus action tools, which keeps the boundary explicit. Read the data, inspect tasks, and then pick routes so nothing executes by accident. Now that we can tell data from action, we need to parse model returns into application types so business rules live in the app. This example turns a structured return into an application object without pretending an action happened. The model-facing contract would be a schema shaped like ticket, while the app still checks runtime facts with valid. That split matters because structured outputs can make the shape predictable, but your service still owns business validation, such as positive amounts. Raw is easy to inspect on screen. Ticket raw creates the parsed value, and valid gives the handoff a clear pass or fail signal. The visible output shows the parsed order and validation result, which is the safe end of the schema-only path, and avoids calling any external system before checks pass. Parsing and validation are not the same as execution. Next, we show a proposal that must be approved before it runs. This code shows why tool arguments are not the same as completed work. The call object is only a proposed action, so allowed checks both the tool name and the amount before refund runs. In a production app, refund would wrap a real payment or order system. Here, it returns a short receipt so the boundary stays visible. This pattern gives you a place for permissions, limits, idempotency keys, and incident logs before anything changes. By gating calls with allowed, you get a clear interception point for audit and safety. The visible output shows the approved tool result, which confirms that execution happened only after the gate passed. Next, we need to retry and repair model returns without ever touching external systems, so retries must stay on the data side. This snippet keeps retries on the safe side of the system. If a structured return fails validation, The app can ask again or repair the response without calling a payment API, sending an email, or mutating state. Attempts contains one bad candidate and one accepted candidate, and good selects the first value, whose dollars field is actually an integer. The retry count is measured from the accepted item, so it is useful for monitoring prompt quality and schema drift. Because only parsing is retried, side effects remain single-shot and observable. The visible output shows the accepted amount and retry count, which matters because only data parsing was retried. Finally, we want a single place to instrument the decision and the eventual side effect flag, so monitoring is simple. This example pulls the boundary into one compact baseline that can be instrumented. Mode decides whether the request is a schema return or a tool call, while side effect requires both a tool route and approval before refund executes. That single boolean is useful during incident debugging because it separates a model suggestion from an external change. Event captures the mode, status, and side effect flag in one place, which is the start of clean monitoring without mixing concerns. The visible output shows the final route and status, confirming the tiny workflow crossed the action boundary deliberately. To map this toy into a real project, imagine the same pattern around your order pipeline. Use ticket-like schemas for all model outputs. Keep validation logic in your services. Represent external systems with small wrappers like refund, and emit an event containing mode and side effect to your observability pipeline. What this pattern is, a deliberate separation between schema returns and tool calls, with the app owning validation and execution. When to use it? Whenever an LLM can suggest something that might mutate state, like refunds, emails, or database writes. One caution: structured outputs make shape predictable, but the app still needs runtime checks for correctness and security. Try one focused next step. Tune how many validation attempts you allow for structured returns, and add a required item potency key to the refund gate, so retries never duplicate side effects. That pairing will improve reliability and make monitoring meaningful. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.